In this lesson we're going to be looking at ions and formulation. That's to say, we're going to be learning how to work out the formula of a compound by considering the ions that are involved in making that compound. So let's just work through some examples to understand how we do this. We'll take, for example, sodium oxide. So we know straight away that sodium oxide is made from two elements, sodium and oxygen, and let's see what happens when the ions are formed first of all. So we remember that sodium's in group 1, the periodic table, it's got one electron in its outer shell. It needs to lose that electron, and as it does so it forms a sodium plus ion, whereas oxygen is in group 6 of the periodic table. That means it's got 6 outer electrons. It's got to gain 2 electrons to form its ion, and so it will form the oxygen 2- ion. Okay, so let's look at the electron configuration for oxygen. As we just said, it's got 6 outer electrons, and it's going to gain 2 extra electrons when it forms its ion. So it will form a 2- ion. So we have a sodium ion combining with the oxygen 2- ion. And how is it going to do that? Well, because oxygen's got 2-, sodium's only got a plus, then the oxygen must combine with 2 sodium ions in order that the charges get balanced. Okay, so that's what we want to do when we're establishing our formula. We need to make sure that the charges on the ions all balance each other out. So we've got 2 pluses there and 1 2- there, all balanced. And then you just look at what you've got. Well, we can see we've got 2 sodiums, so the formula for sodium oxide will be that, Na2, 2 sodiums and 1 oxygen. And there's our formula. Let's go on to another example. Okay, so calcium bromide. Well, again, we know that calcium bromide is made from 2 elements, calcium and bromine. Calcium's in group 2 of the periodic table, bromine's in group 7. So let's look at the ionization equations for each of these. Calcium, we want to lose its 2 outer electrons to obtain the stable configuration, and as it does so it will form the calcium 2+ ion, whereas bromine, which is in group 7 of the periodic table, it's a halogen, it has 7 outer electrons. It wants to gain an electron to get a completed octet. Okay, so it's going to gain an electron to form the bromine- ion. Let's look at the electron configuration for bromine. Again, it starts off with 7 electrons, and then it picks up this extra electron here denoted in red, and that forms a - ion. So we've got a calcium 2+ ion here, and that's got to be balanced by 2 bromine- ions. All right, we've got to make sure that the charges are balanced, and the only way we can do that is if the calcium 2+ combines with 2 bromine- ions. So we just look at what we've got. We've got calcium and 2 bromines, Br2. And there we have the formula for calcium bromide. Let's go on to another example. Okay, for example, aluminium chloride. So you know that aluminium chloride is made from 2 elements, aluminium and chlorine. And again, we think about what's happening in terms of forming the ions. So aluminium's in group 3 of the periodic table. It's got 3 outer electrons. It wants to get rid of those to form an ion. Okay, it's going to do that to form the Al3+ ion, whereas chlorine, again, as with bromine, is a halogen, it's in group 7. It's got 7 outer electrons in its shell. It wants to gain an extra electron to form the chlorine- ion. Look at the electron configuration again. It starts off with 7, okay, and it gains this extra electron here denoted in red to form the - ion. So how are these going to combine? Well, there's only one way that they can combine. The aluminium 3+ must be matched by 3 Cl- ions so that the charges balance. Okay, we've got a 3+ here and then 3 minuses, gives us a neutral compound, and that gives us the formulation again. Just look at what we've got. We've got 1 aluminium and 3 chlorines, aluminium chloride. Okay, finally a little bit more complex example, iron 3 oxide. And notice that in the transition elements they sometimes have multiple valences, so they have a tendency to form more than one type of ion. So in the case of iron, it can form an ion with a 2+ charge or a 3+ charge, and the type of ion that is formed is denoted by this number here. So because this is iron 3, that tells us it's forming a 3+ ion. Let's just write down what are the elements involved first of all, as we've done in all of the other examples. So we've got iron and oxygen. Alright, so we're going to form the iron 3+ ion because it's iron 3 oxide, and it's going to lose 3 electrons. It's going to lose 3 of its electrons to get that stable configuration. Oxygen, however, is in group 6. It's got 6 electrons. It wants to pick up an extra 2 in order to get the complete octet. So it picks up 2 electrons to form O2-. Let's just look at the electron configuration for oxygen. Okay, there you've got your 2 extra electrons that have been picked up as an O2-. Now, how can the Fe3+ ion from the iron and the O2- ion from the oxygen combine to form a neutral compound? Well, there's only one way they can do that, and we're going to represent it like this. So we're going to need 2 Fe3+ ions. That gives us a charge of +6, and as you've guessed, 3 O2- ions. And so we look at what we've got. We've got 2 iron ions here, so that's Fe2, and 3 oxygen ions here, so that's O3. So there we have the formula for iron 3 oxide.